Hi, good afternoon, guys. Welcome to the Industry IoT virtual workshop series. I hope you can all hear and see me okay. As most of you are aware, today's session is with Volkard Regula, who is one of the VPs of Global Manufacturing and IoT over at HPE. Brief introduction to the session in terms of the themes and the topics: adapting to the factory of the future, enabling and transforming the digital value chain. So Volkard will speak about, some smart factory application, digitizing supply chain and associated manufacturing processes, etc. What we will try and do, Volkard has some slides and some visuals to show you. There is an option for you guys to engage in a Q&A at the bottom of your screen. You'll be able to post some questions and Volkard can do his best to answer them. So perhaps after every couple of slides, Volkard, if you have any questions for the attendees, people engage in discussions. We have 60 minutes, so we can leave some Q&A to the very end. But if you have some questions on the way, then please do post them, and I'm sure Volkard will do his best to answer them for you. So, yeah, that's enough from me, and over to you, Volkard.
Thank you very much, Dan, and good afternoon, everybody. So Dan kindly introduced me in my role already. So I head up both operational role inside of HPE. I have a direct responsibility for our client business relationship in the manufacturing automotive industry, as well as a strategic role of bringing the go-to-market program from HPE, the IoT side to life. Let's make that interactive. To Dan's point, shoot out questions. I think the tool takes always a minute or so to get acquainted to. But by all means, I think it gets more out of the discussion if we share thoughts, etc. I will take some of those questions in front to stimulate that one. So let me walk through the agenda, what I had in mind. I wanted to first recap a bit on Industry 4.0. It is, of course, a more pervasive topic now as it was years ago, but certainly good to look at from a transformation perspective. I'd like to take you into the supply chain digitization we've done at HPE. The reason why I'm using HPE, it's a safe environment for me. I can share most probably a little bit more than what you were able to share in a client context, minding confidentiality, so I can go into any details you'd like me to get to. Then on the side of how we address digital transformation, we have developed a use case taxonomy, a bit intellectual term here, but it's actually an architecture behind the use cases with some order and structure, and really have a clear linkage to how to support the digital transformation all around. And then if we have time at the end, we can sort of think about where does this all go. We have a lot of ideas, of course. You may have ideas, and that would be beneficial to share those too. I mean, artificial intelligence, closed loop manufacturing, these are all terms coming up. But they may approach us much faster than we anticipate now. So it's a good thing to maybe look ahead of us and kind of peek behind the curtain what's going on. So far, so good.
Hi, Volkard. Sorry, just 1 second. I'm not sure if it's just me, but it seems to be pretty quiet. I'm not sure whether it's my headpiece or your microphone, but your voice seems to be quite faint in the background. I'm not sure if there's I'm not sure if you can turn that up at all, or if there's a setting. If not, maybe it's just mine.
Yeah, I don't see any way to turn it up. Is that better?
Yeah, that seems to be much better, I think.
Okay, let me. I'm looking like an astronaut, but
no, that's a lot louder and a lot clearer for me, Volkard, and I think it's the same for the others as well.
Okay.
Thank you for that. Cheers.
No, thanks for steering me. Of course, I can hear you loud and clear. So that's the agenda.
let me get started with, okay. Now the sharing. So I cannot, while it worked earlier, I cannot advance the slides right now. Okay, now it works.
Yeah.
So when we talk about moving to a digital world, I sort of want to start here on just getting a reference to a person I truly admire in the context of innovation, which is actually Walt Disney. The reason why I bring this up is, first of all, we have a long association as HPE to Walt Disney, so we've equipped the whole production over a long time with HPE gear. So actually, the voice of Mickey Mouse here was actually one of the first products which HP developed and synthesized voices and digitized their production. And the other reason why I'm referencing Walt Disney is because he was an ultimately creative person in making the change in the movie industry and in his company. But at the same time, he was absolutely ruthless and consequent in how to transform his business. So he was really a master in taking an idea into practice. And that's, for me, a clear reference and role model in the industry, which I have in mind when we talk about transformation of digital world, because very simply, we have all a lot of ideas. A lot of them are in conferences, they're on the drawing board, and a lot of them are staying there and they are never turned into practice, or what I would call the big credit point, the ROI from it, or the business outcome the digital transformation should achieve. When I look at Industry 4.0, it is not only on transforming a process into digital world, it's way more. It has also to do with transformation in a 360 perspective, and a lot also on the social side. And that's the point I'm making here. Industry 4.0 is called the fourth industrial revolution. And I want to make sure we keep in mind that there was a lot before, which we need to keep, which we need to sustain and build on. And when you look at the first transformation which happened in the industry, was really around production from hand to machine. And when you look at all the list of things in the second industrial revolution which happened, there's actually a big improvement of the life and the living standards in the society. And this is coming back now when we push the limits even further beyond the fourth industrial revolution. Because when we see what's coming with artificial intelligence, will fundamentally transform again the way we work and how the people look at work, their personal satisfaction, or in many cases also a risk that their jobs may go away. In the third round, the third revolution, it was all around networking, the internet and the web. And the fourth one is the digital transformation, all into digital and a data age. And I'm pretty sure you've heard many analogies, but data, we need to keep that in mind, and that's our thrust at HPE. Data is useless if you don't do anything with it, and if you're not building the application around it, which is utilizing the data. But when you look at what's going to happen, it's really ahead of us, a profound, and that's the last point here, profound and systemic change. And it is a social revolution, how people interact, how they work together. Think about car sharing, sharing products, and sharing economy. And for us in the manufacturing part, it's really connecting the usage of a product with the whole manufacturing process. And when you think about, particularly in the context of high quality manufacturing, years ago, it was actually a sign of weakness when customers came back to you and talked about your product, because we thought there's something's wrong with the product. And really this understanding that the client usage of a product is fundamental to the improvement design process is what this is all about. Now, again, if you have any questions, if I'm not clear on the points I'm trying to make, please shoot them out and we will deal with them one by one. So when you look at industrial digitization, then particular on the side of supply chain in core manufacturing, the world is very conservative. And I think this is rightly so, because we would not touch a complicated manufacturing system when there are no big rewards. And the rewards you see here are grouped in a number of points. So what we are seeing is whenever manufacturing organizations or bigger companies, manufacturing companies, are driving into applying new use cases, digitizing the process, they have a very high expectation. And the expectation creating an ROI is at least in the double digit, and most of the time in the mid double digit perspective. And it's about inventory, after sales, and you see what's on the chart. So for us, when we go into manufacturing transformation projects, we do have those parameters, those KPIs in mind, and we typically measure the outcome of the digitization project against those. And in many, many cases, we can't even get started or agreement with our customers if those numbers can't be proven or they hold. So when you go to that, maybe we can start with the first dialogue and say, are these requirements which you see in the chart, are you familiar with those? Would you see that they are completely different in your case, or are they too high, too low? Have I missed any of those points? Let's check a little bit where your head is. Dan, can you see any response? Anyone?
Yeah, just checking now. Everyone has the opportunity to post any questions in the chat room or the Q&A. We'll leave it a few seconds, but if we don't see any, then perhaps we can just continue. And when people want to ask you something, I'm sure we'll see it pop up there. Okay, give me 1 second. Yeah, Mirko from Pfizer just mentioned that he agrees on the drivers.
Yeah. Okay. All right. There's still some comments that the audio is low. Is that been? No, it's I see it's 05. It's a couple of minutes ago. All right. Any other comments from the audience? Let me move on in the interest of time now.
Sure.
Okay. So when you look at HPE, and that's most probably the only slide about HPE I'm talking about, what we are really driving in the digital transformation as a technology vendor. We're really looking at all of the transformation projects as to where is the data incepted. So where is the data coming from? And our technology is actually driven to get as early as possible in the process by inventing and developing new form factors and really getting the data as quickly as possible to the core. And that is actually something in the manufacturing industry where we are quite notorious about because the data which is generated in the manufacturing area is the one compared to other industries which is least used. So there's a huge potential in exploiting the data in the manufacturing process. Right now, our calculation is that about max 10 to 15% of the data which is generated in the manufacturing processes are used and really ends up into a corporate system, into the ERP system, into the SAP system. So that connectivity is something we are really looking into and provide compute capabilities to do that connection. Compute capabilities is of course fed by networking capabilities, and it needs to be all secured. And that's where we invest our money and invest our efforts to really take the data, standardize the data, process the data as early as possible where it's incepted. We think it is in the ballpark of 60 to 80% close to the machine, then screen it, cleans it, rinse it, so to speak, and then accelerate the the connection to the ERP system or the MES system, the PLM system, which is on the way. Well, whenever we look at the business aspect in really having a connect of manufacturing digitization, we see actually all what companies are doing when they digitize their processes and introduce new models. Then all what they do falls in either of those four quadrants, or it's actually in many cases a combination out of different models. So many of the new business models as a result of digitization you see are falling still in the defense area. When you look at the automotive part, when you look at car sharing, these are defense strategies. And of course, things like you've seen a number of times on Uber are more on the disruptive side. So everything actually we see more and more connects from the manufacturing side of the digital transformation to the whole corporate digital agenda. And that's a close connection, increasingly close connection between the digital people, the manufacturing IT people, and what we see more and more, the chief digital officers or offices we have in companies really working together in planning out a roadmap. And I share with you later on what we have done with some clients end-to-end transforming that. Complexity isn't our friend. I think we do have a tendency as human beings to drive complexity into our system rather than simplifying it. Of course, simplifying too much will lose the detail. We have to be really conscious about it, that we keep it in an accelerated path. Let me move to the second part of the agenda, which is really what we've done in HPE to digitize our supply chain and how we've approached it. When you look at our supply chain, just give you a little bit of a scale of it. So every 60 seconds, we ship quite a bit of products. We have a pretty complex supply chain, and we had a strong need to digitize it for a very simple reason. If it is all around data, then particularly in the way distributed manufacturing on the compute side works, it's highly distributed with OEMs, ODMs, and we actually don't have control or had control prior to starting with a transformation project of our data. Actually, when we want to exploit the data, not that we did in the past a pretty bad job in doing it, but also the data resides in systems which are not connected to us. And actually 80% of the manufacturing relevant data was sitting with our suppliers and was sitting in a very distributed way, and we couldn't get a hold of it. So you see the essence of the process and the essence of the project we were driving. So we have around 20,000 engineering interruptions in our manufacturing process every month. And that has led us to really controlling these interruptions on a very different way. Well, after really looking at a number of ideas, we came up with a methodology and saying, how can we come to a data-driven supply chain, into a data-driven organization overall, by really looking at a set of starting points where we said, let's test some technology, let's put the data which that technology generates into a database on a local level, and then connect all of the manufacturing places into really a super regional or a global analytics tool. That is a transformation, just to be very clear, that's a transformation which didn't happen overnight. We were talking about a 2 to 3 years transformation and really developing what we call a worldwide order book. And it actually has helped us tremendously over the last couple of quarters. You may know that some of the manufacturing places were actually taken down by massive natural catastrophes. We lost 2 manufacturing places, one in Houston and one in Puerto Rico, which is a great impact. So it's a nightmare for supply chain people. And because of having a worldwide order book, we were able to route orders which were configured to order at one end, but also built to order systems. And we were able to route those orders into other manufacturing places. And we actually supplied the whole United States from Europe with goods manufacturing in Czech Republic and in Germany. And so literally every night, multiple jumbo jets, cargo jets were leaving Europe and put those systems and goods to customers worldwide. What we found actually in digitizing supply chain with all the multiple stakeholders and interests, that we needed a set of KPIs where we could rally the entire company and the entire supply chain organizations around. And the KPI we came up with, which we found is really unifying all the interests, is looking at what's the accuracy of the first shipment date at the point of order entry. Let's say you have an order which you book into the system today, and you say you're going to ship it on the 8th of May or 9th of May, and how accurate is that data point? And the whole supply chain and all the digital processes around it and the improvements, new systems we put in, are all zoomed into that KPI. That means we measure on a regular basis that all of the supply chain digitization projects have an impact in stabilizing and driving the accuracy of that single KPI. And that really helped to measure all of the outcome, the business outcome of the technology we put in. The second thing, which is something we use now heavily for our clients. I mean, manufacturing, as I mentioned earlier, manufacturing people are very conservative. The systems are complex, and you really have to convince people very hard to change something if there is not a massive outcome associated to it, on one hand. On the other hand, all of the manufacturing people have learned a very linear project implementation methodology, which is basically the good old waterfall model. And what we are pushing and working with manufacturing leads in those digital projects is really having a more of a development operational, which is DevOps or Scrum-based model, which is very much coming out of the IT environment, that we're really taking new projects into hypothesis, do very quick proof of concepts, and then after the implementation, measure the outcome and scale it. That has really reduced cycle time of new digital projects tremendously, and we're taking that experience and methodology out to our manufacturing clients when we put IT into their supply chain and other parts of it. The other thing what we did is we were very ruthless on our own side in looking at digitization technology, which is around there. There are a lot of toys around, lots of nice gimmicks you can implement. But what is very important, even at our end as a technology company, that we scrutinize very hard and understand through that cycle methodology, what is the implementation effort? How hard is it really to take a digital project or transformation project into life and measure this very clearly against an ROI? So what we do, and no matter what crazy idea we come up with, we measure it and group it into that quadrant. And that helped us really a lot in scaling as well as in scheduling our improvement projects according to that list of priorities. And we have developed methodologies which we take into the manufacturing environment, where we work with a set of 10, 12 people and really do some ideation and look at that and really schedule then the implementation according to the more life cycle approach I showed you in the previous slide. This is, for example, something we did on our own IT. We really started to rationalizing all of the manufacturing IT we've done. So we took a lot of the IT which were in the manufacturing place into a highly virtual model. We've actually put a cloud, an on-premise cloud system into our manufacturing places, worked on the application, modernized the application greatly. And that should just give you an impression how big the ROIs and the reductions are from a space perspective, from an energy perspective, tremendous savings on the energy side as well as on the space side by really doing those projects overall. When you look at the benefits we have achieved in digitizing that, so our cycle times literally in producing a large 19-inch rack on the IT side has really done in half. our accuracy of the first order entry has tremendously improved. And what we also learned is all of I would say, the data lakes we put in place with our partners had led to a standardization, had led to efforts on their side, because they have seen a totally different platform they can link into. And I would say we've turned around the data control from a 20/80 into an 80/20. And over that process, and you've seen that with the 4-quadrant chart, we were able to really engage our workforce very differently. And apart from the pure monetary aspects you've seen, that's most probably the biggest fringe benefit we've achieved, because people have a different purpose in the manufacturing place. They have way more connections, they have way more understanding, a way higher motivation, which led at the end also in an improved quality of what we produced and what we created as an outcome. So let me maybe pause here again and check with you whether that makes sense, whether that is a useful input for you to drive, and there are some models already you can take in your practice or day-to-day life.
I think if anyone has any comments there, if you post in the Q&A section, the box, I believe, Volker, you could probably see that if people post any questions. So yeah, if anyone has anything to ask or any comments, please add them now.
Okay. All right. So let me go to the next chapter of the agenda. So when you talk about digital transformation, you need to get those into projects and really implement digital solutions in and around manufacturing or in the wider sense of the enterprise. So what we found is really needed is that we look at all the use cases, because every day I'm working with clients, there are new ideas coming up, new use cases coming up. And what we've done is we work with clients, but we also work with industry analysts like Gartner, like IDC, and capture a wide variety of ideas, of things, of packages and digital projects which we see in the industry. And what we've done is we've looked at those use cases. Okay, we looked at those use cases and grouped them in 3 parts. So we found that these use cases in driving digital transformation are either within buildings, so they drive building out automation, they drive the positioning of people, locating people, and servicing people depending on where they are, either finding a place, finding a meeting room, taking material or services to people depending on where they are and what they need. So that's one of the big use case groups we have. The second one is all around industry use cases. Of course, everyone thinks first on all the predictive use cases you have, predictive analytics. The reason why most of the people start with those use cases is because of their ROI. It's very easy to measure, it's very tangible, and there's a lot of technology you can implement now. And there are also software applications and strategies with the large software vendors like SAP or PDC, which are big players in that digital transformation. And they really have tangible products which you can take as products and you can take as service and drive those throughout the industry and the manufacturing place. The third area is really around cross wide area networks or wide area in cities, and really connecting vehicles, connecting people outside of a closed environment, out in the open where they live and what they do. When you look at some of those high-level use cases, then in manufacturing, you see condition monitoring, predictive. You get those slides so you can look at them, but I wanted to offer you that as a structure of the most high-level things which do exist. And you can take that, of course, and say, do I see the same what's behind them. And all these use cases are fairly well structured in terms of how you can exploit them, or first of all, explore them, understand what's behind it, what is it you need to change to implement them, what KPIs do they support, what is the investment level you take, and also what's the project life cycle. So how long will it take to use those cases in your own environment, rather than just talking about it. It's very output driven, business result driven, and life cycle driven, how you can really take that into implementation. And you see transportation, buildings. So we actually use 8 levels of our taxonomy to group all what we've seen so far. And as I said, there are way more coming. So every day I'm working with clients, new ideas, but the structure overall in those 8 blocks has kept stable for quite some time, and a lot of people increasingly use it. Let's go into the industrial space. So when you zoom into it, what is it we see as a digital transformation projects mainly coming around? I mean, we see particular on the more complicated manufacturing side, not necessarily only automotive, that we can take a lot of the manufacturing into the virtual world. So the physical and the virtual world are getting closer and closer, and that has to do with the increased compute power which is available now in the marketplace. I mean, the compute power is at right now at a kind of a saturation point. So the old laws, you may have heard the Moore's law, which assumes a certain increase of compute power over time as a steady evolution, is sort of at the end. So compute power needs to be completely re-architected and revisited, but still we have enough to really drive digital design and digital simulation from a cost perspective. That is a fundamental saving companies have. I mean, of course, everyone knows that if you do a crash test with a car or with a product, that this is very expensive, not because of the product only, but also when you do that, and when it's part of the design process, then you have to do that very early. So the car which is crashing against the wall is not a 50,000 euro car, it's actually a 2 million euro car, because it's a handmade Series 0 production car, which costs a ton of money in order to find out what it is. So simulation is very important on the supply chain. We talked already a lot about it. Digital factories is a big integration we see. We call it a horizontal integration along the various steps of the manufacturing process. We've seen several projects where people are really looking at how can we maintain all of the assets in the manufacturing place and utilize those assets. One of the biggest use cases we were involved in is when you bring out a new product, you have to really use your first mover advantage. So any of the car manufacturers actually, when they have a winner, when they are producing a winner, they typically can sell way more of that product, and you see it on the shipment times. They can sell way more of that product than what they can actually produce. It's a very common issue manufacturers have. So the concept we have developed is really looking at stretching the manufacturing process and stretching the material and stretching the machinery up to its limit. And so we actually have figured out with algorithms how can you really go at the very high end to the machine utilization until it breaks down, and measure the whole business case against the increased revenues. So we spend more money in maintaining equipment or running the risk of failure, understanding the potential downtime against it, and measure it against the first mover advantage and the increased revenue. So this is the state-of-the-art digitization which is happening in the manufacturing place. Above and beyond, there's a lot of savings overall in maintenance costs, but we also look at, as said, in the outcome and the business case by having more product sales along it. And the last one on the list here on the right side is actually the one which is, from my perspective, furthest down the road. And these are actually not new models. Not an accident that you see an engine, an airline engine. We have already up in the air jet engines, a ballpark of 40,000, which are really sold as a service rather than they're sold as a product. They're really sold by the hour, and there are many, many companies who are driving that. And for us as an IT vendor, it's also very important that we follow this trend with our own offering. So if our customers are selling their products way more as a service, and from the IT industry, you most probably know this very well. So when you look at SAP, the HANA Enterprise Cloud, and all of the new technologies, they're meanwhile several years out in the market, and that business transformation has been done very successfully. But that's a front runner. It will happen with hardware. It will happen with core products too. And when the clients or our clients are selling their product as a service, then they won't buy products from us. So not only the software part, but also the hardware part, the technology part will be sold more and more as a service. And we're actually transforming a great part of our business to really drive it as a flexible capacity and taking a lot of the risk of the utilization of the product, its uptime, onto our shoulders, so that the business model transformation can work effectively at the client side. So it's an ecosystem. Everyone has to contribute to a changing model to transform to a digital manufacturing place. So conscious about the time. When you really look at what the art of possible is, then it falls into four groups, which you see in the center. We see more and more self-learning productions. So artificial intelligence is moving aggressively into manufacturing. Honestly, I have underestimated that trend. I was thinking that would take quite a while, because when you look at AI, the IQ today of the best machines is roughly at 50, so it's way less than half of a human being. I was also counting big time on the emotional component, which is really missing quite a bit still in AI, but there are way more use cases on self-learning production and closed-loop manufacturing than we've expected. So a lot of the investments we take is actually in that part. As a company, we have launched a whole suite of AI solutions last week. That's actually very timely to drive that and drive it really down into areas where people are not IT experts. So these technologies are now available almost as a consumerized product. When you think about the consumerization, I mean, we all know this from sitting in front of the television potentially, or being home. You have a myriad of applications on your handset which drive your personal life. That was the first step. The second step was actually consumerizing the enterprise applications. I mean, today, all of my CRM system, my communications, my order tracking, my own payment inside of the company is consumerized. I have it on my handset and I can access it every point in time. But in the manufacturing side, this has not happened yet. So what we're really looking at, how can we access and transform on the manufacturing side, a consumerization is really offering manufacturing plant managers a whole set of applications they can deploy very quickly. So they understand that something is wrong, they can access the sensor data, and they have very quick applications which they can pull down from a portal, which we put straight in their manufacturing site, and can construct that application pretty quickly, do a quick history and analytics, so understand the history of the data, draw some conclusions, and move on to the next part, what they're trying to assess. So that's something which is really coming, and it's clearly around the corner. The first systems we have implemented, and they network to all sorts of cloud providers where hosted applications reside. And that's basically the same then of what you see in the other two parts on the enterprise side. and the overall private lifestyle. Preventive maintenance is, I would say, a classic, but is by far not utilized to its fullest yet. Digital twins, we talked about it. Digital plant floor, we talked about as well. So we see on our taxonomy, these are the 4 major projects on the manufacturing place. And we have cases where we're working with clients on all 4 of them, and really start from getting together and formulate the ideas, develop the project plans, and really implement those technologies according to the 4 quadrants you've seen. Yeah, really looking at the low-hanging fruits first. Where are the technologies so we can do straight away, and take those which have the highest business outcome overall. You get those slides as a handout. I can't walk through all of it, but there is a whole set of really tangible things people can do. So if you look at the key priorities, are you seeing the same at your end? Just making a pause there. Or are you seeing this is too far out? Or maybe you're already further down the road of what you see in your environment. Let's check that quickly. If you have any comments on that. Just want to make sure I'm not losing you. And do you see any comments at your end?
No. Oh, okay. So we have. I'm not sure if you can see the Q&A box, Volkard, at the bottom of the screen there,
yeah,
but
yeah.
Yeah. So you'll see the question, and I guess you can.
Yeah. So yeah, it's from Colin. What about 3D spares? I'm assuming that's 3D spare parts. That is huge. That is absolutely huge. So augmented on one end, but also additive. We see that particular when things are moving. So I would say my big bet is wherever spare parts are very difficult to travel to. Let's say you have an aircraft carrier. Digital technology would already tell you when the plane is up in the air, because the jet engine is also very digitized already. It's difficult to get the data because they're producing a tera data an hour to get them down. But you basically know by the time the plane lands already on the carrier what needs to be repaired. And you can't have all those parts possibly, particularly when you look at the military space. You never know what's happening and how they're used. We see a lot of test cases and real production cases. We even see the production capability now of complete turbines, which can be produced with additive manufacturing. It's phenomenal. There are parts which are incredible. When you look at, for example, at General Electric, what they exhibit right now and what complexity they can produce additive, great stuff. Big market for us. But you need to get prepared. You need to know beforehand what are you producing and schedule that, because it still takes time, which is a disadvantage here. Sometimes it takes quite a couple of hours to produce it. So you need to have the data and launch the manufacturing process around. So I hope that clarifies point of view on it. Right. Let me just close it.
Do you? I'm not sure, Volkard, if you can see the chat room as well. Do you have access to that on your end?
Yes, I do.
Yeah. So you'll see there's a message from Sergey.
Yeah. Okay.
Yeah.
Okay. Right. Yeah. Understand. I concur with it, Sergey. So preventive maintenance. Let me just cover that one. It really depends what it is. My big bet where we are putting our investment is in the whole market of retrofitting. And I show you a case on a refinery. We actually developed a model called the refinery of the future. You need to be selective. We see a couple of manufacturers who build small boxes. For example, ABB, they have a nice box which contains, maybe it's just a little like a small drive you have, a small, I would say, double the size of a cigarette box for those who used to smoke. And you can take that box with about 20 plus sensors and attach it to the machine and bring it close to where the action is, connect that with a Bluetooth low energy environment directly to a switch, and start working on historian analytics and do some predictive parts. So for example, on pumps, preventive maintenance is quite advanced meanwhile. We can, particularly in refineries, where critical pumps would bring down the whole plant, we can actually predict by the hour when the pump would fail and can schedule unplanned downtime. So that part has progressed, but overall, it is still a long way to go, but I find it exciting because there is every day new technology will drive that. But the business case is so good on this that I think nobody can afford to not invest in it. And we as IT vendors, we put a lot of effort with partners, with SAP, with PDC, on understanding that more and more. All right, let me should move on. So if you can keep, because I have to switch something on the screen, then if you keep an eye on the chat room.
I will, yeah, sure.
That will be good.
Yep.
So, that's most probably my last sort of topic for today. The big difference is, from my perspective, really made in the how you address that. If a strategy without execution doesn't get you any results, that's hallucination and not really driving outcome. Our use case model, where I think we are furthest down the road, is actually on the process side, as well as on the discrete manufacturing side. On the discrete side, I had a couple of examples earlier, but let me go into the process side to showcase on how we do that. So we actually developed with a client called Texmark in an ideation workshop, which we can do with almost any clients. We do that on quite a regular basis, and these are 1 and 1.5 days workshop, and do some ideation on what's the art of the possible. And that's what we've done with Texmark. What's the vision of the refinery of the future? What are they trying to do? And actually, preventive and predictive, no surprise, came up as the first use case. So what we work with a set of innovative companies, which you see on the top right. So Enios is a company who have developed alongside with the client and with our help, have really developed a complete digital image and a digital twin of the entire manufacturing place. It's still a while until everything is set up and running, but you can increasingly simulate the whole manufacturing place on the screen. The company Flowserve, you may or may not know them. Flowserve is quite an interesting innovator because they're in the pump business. They really looked into, can they sell actually the flow through the pump rather than the pump as such. So you see how far the as-a-service model is going already, and the sky is the limit. So we work with them because they look at business model transformation and really look at the content, what flows through the pipe, rather than how can we really monetize or sell the pump and sell the equipment as an asset. National Instruments is one of the leaders in sensor technology, and they've worked with us on really boxing and retrofitting the whole plant. So this is the approach we took. So we really looked into an ideation with the client, looked then at business model changes with the suppliers, with the clients, and then went into transformation. So we never stop, and we're not in the business of doing ideation as such. We ideate for a purpose, which means for really driving to a new model and driving to an outcome. This is how it looks like. Typically, when we're saying we want to really take a new approach to the refinery, we look at all of the components on the IT side, on the edge, on the use cases, and build over an architecture and say, how can you take the linkage between the various elements you need to have with the outcome. So that's part of the first step, and you've seen that slide before. And then what we came up with as part of the workshop is the 2x2 got evolved into a 3x3, where we really said what is feasible and what is more complicated and what's the outcome. And then we've designed with the clients typically how we do that, not more than 9, 10 of concrete projects of what we can do. We phase them, we scope them from the timeline, we associate the delivery methodology with it, and scope it in terms of how we can do that. And what we need to do is resources, both financially and technology, and then really start in taking this into a project plan. I've cleaned it a little bit because there was some confidential information in it. And for Texmark and the Refinery of the Future, which a lot of companies have meanwhile visited, because that is our showcase manufacturing for the process industry. We've started with predictive. We looked at the weak points. It was about the pumping part of it. We're now moving into an area where we look at video as a sensor, which is a very interesting piece because you can visualize and you can actually see a leakage. You don't necessarily need to implement complex sensor technology. And then the third level is really connecting the workers. In complicated manufacturing plants, accidents do happen. Accidents, in particular, fatal accidents, injuries, serious injuries, are a core KPI. So the CEO of companies, they typically, when they announce to the shareholders some of their KPIs, that's part of it. Injuries, accidents is part of it. And unfortunately, it happened many, many times that the current technology doesn't allow you to really protect the workers and find the workers in case something went wrong. So they do have today radio equipment. They can signal, hey, I'm down, so man down is the official signal in the refinery, but then they can't find the people. And when you listen into the radio, it's bizarre how difficult it is to really locate a person. And location technology and geofencing is the term we are using, will be the new name of the game, really protecting workers from places where they should not be, or places where it's overcrowded already because they can't pass, or also looking at, and that needs to be all done, of course, with workers' councils, etc., but also protecting the workers from dehydration, from a lot of those things. So these technologies in connecting workers, protecting workers, doing geofencing, and understanding how we can do that is a phenomenal business case, because in larger manufacturing, you have to accrue quite an amount of money for accidents. And most of those accidents are not insurable risks. You don't find anyone who really covers this with a policy. And imagine you can deduct all these accruals or remove them from your balance sheet, then you have a big impact. And that's the roadmap we have outlined on that site with the process industry. Yeah? So that's part of that. And just to restate, on the discrete side, it is really building strongly digital twins, connecting the machinery on a horizontal level to integrate the manufacturing process. This is all what Industry 4.0 is about. Make sure the asset is utilized, can be maintained, and you really can drive it to the limit, in particular when you roll out new projects and new processes. And so far, compute power is there. It's growing quite nicely, but as I mentioned, we have to re-engineer computing completely. And it will take another 2-3 years until that is done. because the architecture in the future will be memory centric. That's not processor centric like it is today. So basically you have a big data lake, and then you take purpose-built agents and exploring, and that you drive processing power which accesses data. And so from an energy perspective, it will be done based on new memory technologies, which have a different form factor, and also less copper. So there will be photonics in the future of IT. So quite exciting what we're seeing to really catch up with that. Just to give you a bit of an outlook on the sheer data. When you were, famous example, when you were to go into autonomous driving, the cars really already produce 1 terabyte an hour. You can't store that easily. Even the current tests which happen, which are 800 to 1,000 cars, fully automated cars, which are in a country, are deployed. You just don't know how to get the data off the car. And the big car manufacturers, they need 7 to 10 petabytes of data in real time to do the crunching and to really do autonomous driving. Even the bigger ones who have many more. So the market leaders like Volkswagen and Toyota, they're talking about even more. They're talking about 10, 12, 15 exabyte of data lakes to explore. So that part, as also mentioned earlier, that part will be exciting because we see a myriad of applications developed. With the big ones with SAP, for example, on their Leonardo strategy for IoT, it's quite exciting what's coming down. And for us, the strategy is really to consumerize this and make sure that users in the manufacturing place don't need experts and very rare resources to take advantage of those applications. So looking at the timing, I have of course many more points I could go through, but let me sense the pulse again. Is there anything you want me to cover above and beyond that, or any questions, comments, remarks you have at that point? Q&A.
I think you have a question from Merker.
Okay. So yeah, that's a very pointed question. Actually, we do have a whole series of engagements, panel discussions in the market, and I will be speaking a week from now at the Hasso-Plattner Institute in Germany. We're really looking at how does digital technology as well as AI change the workforce. The first thing is what I would say, it's completely overrated in terms of a job killer as such, because you look at the generation change right now. People are really struggling to find new labor who are capable in doing it. So that part of your question is an important one. It's not a job killer. Is actually investing from our side, investing with manufacturers in training the people and augmenting the people with visual, for example, with visual remote guidance, or with augmented reality, and training people really and the young workforce to use those processes. AI and digital technology is absolutely needed because when you look at the large economies, whether it's France, or whether it's Germany, whether it's the UK, you see that anywhere between 3 and 7 million of workers from the baby boomer time will go out and retire between, I would say, now and 2030. So the technology is needed. I think where the challenge is catching up with educating the workforce, particularly on this refinery of the future with Texmark. They came to us and said, we actually have people who are now who are now in their 60s, which we are dependent on, and don't know how to transfer that knowledge to the young workforce. So that's where we see we need to still focus on the people and how we guide them, how we can train them. I think technology is there. It is about letting go from the more intuitive and transforming and transferring that into the digital technology. But I would say it's an exciting future which we can have, but clearly it won't be a job killer from my perspective. Is that answering your questions? How we're facing the change? I mean, let me cover that part. Actually, that's an interesting part. We went on HPE. We went to a university who does digital education. So there is a new study coming around. There's a master study actually called Digital Pioneering. And we have partnered with those universities and actually took a lot of their students on into our workforce. That's one part. So we actually refresh and educate with bachelors and masters, which really have a solid digital education. But we also took that university and created an HPE digital MBA. So we've asked them to put a curriculum together, which is a 12 weeks program for educating some of our top people who help us to transform the entire company. So as employers or as consultants, as people working in the marketplace, you have to definitely do something and invest quite a number of dollars to train people and put the technology in place. I would love to have an interactive discussion on that with you, Mirko, but I think we need to do it here with the technology. It's digital anyway.
Yeah, I can just so you guys know, I can make the connections after the call if you guys wish to progress the conversations further. I think you have one last comment, Volkard, from Colin. I think quite a few people are about to drop off the call now due to other commitments, but I believe Colin is still on there. Not sure you can see his question at the bottom there.
Yeah. So the mobile control rooms is, I don't know whether you're familiar with, and I need to understand what industry you're in. I don't know whether you're familiar with a concept which is called Arena 2036, where we are researching quite a bit around this. So where a set of manufacturers really get together and really look at that. How you can do that, how you can build out mobile control rooms, or more generally speaking, the whole concept of mobility will be a big one because the manufacturing process will change dramatically, that things will not be on a conveyor belt any longer, but they will be completely mobile. So semi-finished products will pick up their material rather than the material will move to the semi-finished product and add value until it becomes a finished product. So that will be a phenomenal transformation in the industry, and clearly something we are on it. And given when you use the word mobile, I see that mobile technology and secure mobile technology has developed quite nicely, and there is more to come. So when you look at the whole 5G environment, the amount of base stations which are built out, you basically have a complete network of quasi mobile access points, public and private, in the converged environment. So it will be really what I would call a mobile everywhere environment. Let me see whether there's more. Okay.
I think that's it. I think quite a few of the members have messaged to say that they've had to jump on other calls and visit their next meetings. So yeah, I think we'll bring it to a close after that. Volkar, thank you very much. Very insightful, very thought-provoking. As I mentioned, I'll make some connections after the call if you guys wish to progress these conversations further. And Volkar, if you'd be so kind to share the deck with us. Quite a few of the attendees have asked for the slides. And if anyone has any questions that they want to ask you, perhaps I can reach out to you.
Absolutely. Happy to do that.
Perfect.